Bayes' theorem is one of the really important concepts that we have in this particular unit, as this concept is used in later applications, particularly in data mining and classification of categorical variables. So oftentimes we begin with our probability analysis having initial prior probabilities, and then we might have a sample or a special report or maybe a product test to be able to obtain some additional information. And using that information, we can then calculate revised or what we call posterior probabilities. And so Bayes' theorem is going to provide a mean for revising these prior probabilities. It's an alternate approach of calculating the conditional probability, and it can be useful when the joint probability is either challenging to calculate or when we know the reverse conditional probability. So when you have two mutually exclusive and collectively exhaustive events, you can do this. So prior probability, like I said in the previous slide, that's going to be that initial probability based on the present level of information, and then that posterior probability is going to be the revised probability based on additional information. So looking at an example of this, let's suppose that 5% of the population of human has a disease, and A1 represents the part of the population that has that disease, and A2 represents those who do not. So A1 and A2 are going to be complements of each other because you can't have the disease and not have the disease at the same time. So A1 is going to represent 0.05 probability. A2 is going to represent 0.95 probability. Then it says, let B denote a test result that shows the disease is present. So here we know that the probability of B given A1, so the probability that the test shows it's positive, given that we know that the individual has the disease, is 0.90. So we have a 0.90 probability of the test being correct. We also know the probability of B, given that we know the individual does not have the disease, is 0.15. So we have a 0.15 probability of getting a false positive on this test. So now the question is saying the test results indicate the disease is present. What is the probability the test is correct? So now instead of saying what's the probability of B given A2, we need to flop it around to find the probability of A1 given B. And so if we use Bayes' theorem formula, we will calculate that the probability the test is correct is 0.24.